Hey everyone, and welcome to today's Explainer. I'm really thrilled you're joining us because we're about to unpack a massive paradigm shift in how we actually interact with our machines. We're finally moving away from those heavy, bloated systems we've just kind of accepted as normal, systems weighed down by decades of unnecessary visual layers just to render like a simple button. Instead, we're looking at the sleek, powerful reality of what's coming next. So get ready to rethink your entire digital experience. Just think about your phone or your laptop right now. You tap, you swipe, point, click. It feels totally natural, right? Well, it's what we've been conditioned to do. But what if I told you that by relying on these visual abstractions, we're actually severely limiting our ability to communicate with machines at the speed of thought? It begs the question, are we actually interacting with computers all wrong? Okay, let's dive right into this. Here's our roadmap for today. First up, the graphic interface dead end. Then, text, the universal interface. After that, we'll look at how software is literature, followed by command-line agentic workflows, and finally, the magic of authorship. All right, kicking things off with Section 1, the graphic interface dead end. So there's a stark visual and structural contrast between graphical user interfaces, GUIs, and command-line interfaces, or CLIs. Let's really unpack this. GUIs are, well, incredibly heavy. They need massive computational power just to render the pretty visuals you see every day, right? The shadows, the rounded corners, smooth animations, all of it. And when we try to get AI to automate tasks on these graphical systems, we often have to resort to super fragile techniques like screen scraping. Basically, the AI is taking a messy, pixelated picture of your screen and just guessing what to click based on shapes and colors. If a website changes its layout even slightly, bam, the whole automation breaks. It's an invasive layer of translation that slows everything down and introduces endless errors. The CLI, on the other hand, is completely streamlined. It's lightweight, direct communication with the machine's hardware. Instead of rendering graphics, you're generating 100% exact text logs. You're talking directly to the system without all that visual bloat. I absolutely love this quote from the source material. It says, "We get the chimpanzee hitting buttons, but we chat with each other. We could be hitting buttons, but it isn't as good." Seriously, think about that for a second. The GUI essentially reduces us to animals pushing colorful levers for a reward. But human beings are built for deep, nuanced language. We chat, we write, we debate. Forcing us to click buttons actually dumbs down our ability to express complex thoughts to our machines. We trade the nuance of language for the simplicity of a shiny button, and in the process, we're losing so much expressive power. Moving right along to Section 2, text. The universal interface. So the crucial point here is this core definition. Text is the universal interface. It's a shared linguistic environment that works natively for both human thought and machine computation. No heavy visual translation required. You don't have to map a mouse click to a line of code. When we strip away the graphics, we're left with pure, unadulterated meaning. With text, we and the machine are finally speaking the exact same language. And the immediate benefits of treating text as our primary control system, they are massive. First off, we completely bypass GUI bloat and latency. But more importantly, think about large language models, LLMs, like the ones powering today's advanced AI. They're natively built on text. They don't have to look at a screen and guess what a visual icon means. They process the pure, explicit logic of the words we feed them. We can type and converse literally at the speed of human thought, seamlessly bridging the gap between what we want and what the AI executes. Text naturally supports complex, nuanced logic, deep context, and precise instructions that a simple clickable button could never, ever hope to capture. Now, consider the fundamental difference between computer processors and pure text. Computers often rely on what are called floating point units, or FPUs, to do math. They use approximations to get things done quickly, kind of like hastily calculating the square root of 5. It's incredibly fast, but it's what we call lossy, meaning it sacrifices perfect, exact accuracy for that speed. It drops decimal points. Text logs and a command line, however, don't do approximations. There's zero guessing. They are 100% exact, high-fidelity records. Every keystroke is captured exactly as intended. They're forensic, explicit records, perfect for maintaining exact identity and attribution. When you type a command, the machine records that exact command completely lossless. That brings us to Section 3, software is literature. It's time to completely reframe how we view code. The source material makes this truly profound point. We call programs tech all the time, but I believe we'll do a lot better at leveraging them if we recognize their literature. Just let that sink in for a moment. Code isn't just some cold, mechanical set of gears grinding away in the background. It's a highly expressive, exciting continuation of human authorship and thought. When a programmer writes code, they're writing a very specific, operational story. And that exactness of human authorship is the perfect bridge into understanding fields that rely entirely on the precise meaning of words. To really grasp this, just look at the striking similarity between programming and the law. In code, a developer uses a variable to strictly define a specific scope. It's incredibly fastidious. If a word isn't defined perfectly, the code simply won't run. It throws an error. In law, a lawyer uses a definition clause in a contract to achieve the exact same goal: total exactness of meaning. If a term isn't defined, well, the contract falls apart in court. Both disciplines are writing highly explicit, functioning literature where there's absolutely zero room for ambiguity. And that brings us to tools like LaTeX and LawTeX. Now, LaTeX is essentially a document preparation system meant for high-quality typesetting. It's what scientists and mathematicians use to format those incredibly dense, perfectly aligned academic papers. It gives the author absolute, deterministic control over the final printed page. And here's a totally fascinating historical fact. Early markup languages, the predecessors to the HTML that builds our modern web, were originally pioneered by a lawyer, Charles Goldfarb. He created them specifically to manage complex legal data. LaTeX and LawTeX are the ultimate literary tools for securing our specific meanings and intentions, making sure our human thought is perfectly captured by the machine.
All right, Section 4, Command Line Agentic Workflows.
So, how does all this actually build into a robust, practical workflow? Well, it happens in 4 simple steps. First, we open an isolated teletype or TTY channel. Think of this as a direct text-only pipeline straight into the brain of the machine. Second, you input natural text at the speed of thought. You just talk to it. Third, the AI agent reads this perfectly lossless text without needing to decode any graphical interfaces. And fourth, the agent executes the task and logs the exact provenance or history of every single action it took. It's a seamless, highly precise loop where literally nothing gets lost in translation. And the absolute secret weapon here is the PTY, or pseudo-terminal channel. When you use back-end tools like GNU Screen, these channels act as isolated, completely secure users on an operating system. You can detach from a session, close your laptop, walk away, and the AI agent's context loop will continue running safely in the background for days. Later, you just reattach to that channel with zero data loss. Contrast this with modern web browsers, where if your internet flickers for even a millisecond, your API drops, the page refreshes, and you can lose hours of work. PTY channels provide this unbreakable environment for remote AI agents to operate. And finally, Section 5, the magic of authorship. Ultimately, stripping away the GUI and using local, text-based compute is how we maintain true control over our digital intellectual property. This brings us to the concept of sovereign technology. Sovereign technology, meaning tech where you have total, undeniable ownership and control over your own data, relies on strict data attribution. When we use exact text logs, we protect what is called the magic of authorship. We protect it because we can perfectly trace where an idea came from, when it was generated, and exactly who or what contributed to it. The source actually outlines some fascinating methods to preserve that identity. We use unique session IDs out of the box for agents to track their specific actions. We capture human and AI collaborative loops as what the source calls spell chains, which, by the way, is a beautiful, almost magical way to describe an unbroken chronological record of human thought and machine response. And we use cryptographic keys to protect trade secrets, relying on what's poetically referred to as the unbearable lightness of association. Basically, this means we can securely connect our creative thought chains locally, cryptographically protecting them so they can never be scraped, monitored, or stolen by outside platforms or bloated web services. This brings us to the core thesis of this entire explainer. As long as we have the author, we're good to go. Preserving the exact text, the pure intent, and the identity of the author is the unshakable foundation for all future digital and AI systems. It's not about building visually pretty interfaces that dumb down our thoughts. It's about robust, mathematically certain, undeniable authorship. When the author's intent is protected, the whole system is secure. So I want to leave you with this provocative thought. Now that you know the bloated graphical interface is really just a fragile layer holding you back, and that pure text is the ultimate, universal interface, how will you write your own future at the speed of thought? Thank you so much for joining me for this explainer. Keep digging into the command line, and I'll see you next time.